This is a summary of the steps for the critical value method. First, we're going to state the hypothesis and identify the claim. Then we're going to find the critical value or the critical values using the significance level alpha. This is using table F, last row. Then we need to compute the test statistic, the test value Z, using the formula. You don't need to memorize the formula, but you need to know how to evaluate this in your calculator. Then, if this value falls in the rejection region, we're going to reject the null hypothesis. Or if this value falls in the non-rejection region, then we do not reject the null hypothesis. Those are the two possible decisions, reject or not reject. And at the end, we need to summarize the result. We need to write a conclusion about the claim, the original claim in the problem. So let's see the first example. These are the type of problems that you need to know how to solve in the homework and in the test. This is about people who are trying to avoid trans fats in their diets. So a dietitian claims that 60% of people are trying to avoid trans fats in their diets. She randomly selected 200 people and found that 128 stated that they were trying to avoid trans fats in their diets. At a significance level alpha equals 0.05, is there enough evidence to reject the dietitian's claim? Use the critical value method. So, first step, let's go by steps. Identify the claim and write the hypothesis. So, what's the claim in this example? And we need to write it in symbolic form. It's about a percentage, so we know that we're going to use the letter P for the proportion. So instead of percentage, we're going to work with the proportion. Now, what's the claim? That the proportion is what? Equal, not equal, less than, or greater than 60%. In this case, we use the equal. It doesn't say below 60 or above 60 or more than 60 or less than 60. It says 60. So that's exactly 60%. Her claim is that exactly 60% of people are trying to avoid trans fats in their diet. So in this case, we use the equal sign and the percentage as a decimal. So the claim is that the proportion is equal to 0.60. So where do we write the claim? In the null hypothesis or in the alternative? That's the first step. We need to write now the hypothesis, the null hypothesis, and the alternative. So in the null hypothesis, okay? Because in the null hypothesis, we have the equal sign. So we can only write the equal sign in the null hypothesis H0. So what would be the alternative? When the claim is that P is equal to 0.60, then the alternative is that P is not equal to 0.60. Because the opposite of being equal is not equal. So that would be like the alternative in this example. And the claim is the null hypothesis. Sometimes the claim will be the null hypothesis, but sometimes the claim will be the alternative. Okay, the claim could be any of the hypotheses, but in the null hypothesis, we only use the equal sign, and in the alternative, we can use the not equal, the less than, or greater than, depending on the problem. So what type of test is this? Left tail, right tail, or two-tail test? When we have the not equal. Very good. This is a two-tail test. So in the next step, we're gonna have to find the critical value. And for that, we need to know what type of test do we have. So when it's a two-tailed test, we're gonna have to find two critical values. So it's actually two critical values. One will be negative and the other one will be positive, because we're gonna have two rejection regions. So now we're gonna use the value of alpha. So what's the value of alpha? The significance level. Alpha is 0.05. So with the value of alpha and table F, last row, we're gonna find the critical value. So I'm gonna open the table. Table F. And then we need to decide where to find the value of alpha equal to 0.05. Where it says one tail or where it says two tail alpha. How is the test? A one tail test or a two tail test? It's a two tail test, so we need to find 0.05 in this row for two tail test. So this is alpha, 0.05, and now the last row is what? 1.96. So what would be the two critical values? 1.96 and negative 1.96. So on the last row, we always have positive numbers, but depending on the type of test, we're going to use the positive number, the negative number, or both. So for a two-tailed test, we use both, the positive and the negative. For right-tailed test, we use the positive, and for left-tailed test, we use the negative. So in this case, we have two critical values, negative 1.96 and 1.96. So we have two rejection regions. This to the right of positive 1.96 will be the rejection region, and the values corresponding to this area to the left of negative 1.96 is also a rejection region. Remember, the rejection region is also called critical region. The alpha will be given because it's the significance level. The researcher determines what's the significance level that they want. If they want 0.05 or 0.01 or 0.10, that will be given. So now we need the test value. So the test statistic. So I'm gonna put the formula. So try to do it on your own. Find the value of p hat minus p over the square root of p times q over n. So here it's important to know the difference between p and p hat, the value of q, the value of n. You need to follow the formula in that specific order. So it's p hat minus p, not p minus p hat, okay? So what's the value of p hat? Now we use the information in the sample because p hat is the sample proportion. It will be x over n, 128 over 200. So the sample proportion is 128 over 200. That's the proportion of people in the sample trying to avoid trans fats in their diets. So in decimals, this is 0.64. So the first value to be evaluated here is 0.64. Now, what's the value of P? The value in the null hypothesis. In the null hypothesis, P is equal to 0.60. So we subtract 0.60 And now we divide by the square root of p, 0.60, times q. Now q hat, q is 1 minus p, not 1 minus p hat. So it's 1 minus 0.60, not 1 minus 0.64. So it's 0.40. And then we divide by the sample size. What's the value of n? 200. So when you plug it in this in your calculator, when you evaluate the formula and round to 2 decimals, you get 1.15. So that's the test value that we need to see where it falls, in the rejection region or in the non-rejection region. So where is 1.15 located? In one of these rejection regions or in the non-rejection region? In the non-rejection region, because 1.15 is between negative 1.96 and 1.96. So it's in the non-rejection region. So what will be the decision? Reject the null hypothesis or fail to reject the null hypothesis? We fail to reject the null hypothesis. So now we need to write a conclusion. Yes. About the claim. So we need to answer the question. Is there enough evidence to reject the claim? The decision is that we fail to reject. So we cannot reject the null hypothesis. And that's the claim. We cannot reject the claim. So what will be the conclusion? Do we have evidence to reject the claim? No. Okay, there is not evidence, there is not enough evidence to reject the claim. So that will be the conclusion. So you can write the conclusion like this, or if you want, you can write what's the claim. So you can say there is not enough evidence to reject the claim, or there is not enough evidence to reject the claim that the proportion is equal to 0.60, or that the percentage is 60%. So always in the conclusion, you need to talk about the claim. If you can accept it or support it, or if you cannot support it, if you can reject it. And that depends on the decision. So if the decision is that we cannot reject the null hypothesis, then we cannot reject the claim. If the decision was reject the null hypothesis, then we will have evidence to reject the claim. So depending on the decision and depending what's the claim, remember the claim could be the null hypothesis, but sometimes it's the alternative. So taking into account the decision and the claim is how we write the conclusion. So the last step is the one that it could be a little more complicated for you. So this takes practice because it's not always the same decision. The claim is not always the null hypothesis. So it's not something that you can just memorize. You need to think independently in each problem. So in this example, the conclusion is that there is not enough evidence to reject the claim. So you have the solution step by step in the slides. The critical values were both 2, positive and negative 1.96 because the test was two-tailed. Then the test statistic was 1.15. The decision is do not reject the null hypothesis because 1.15 falls in the non-rejection region. So we can summarize the result by saying that there is not enough evidence to reject the claim that 60% of people are trying to avoid trans fats in their diet.